Today in lesson 8.6 we're going to look at quadratic functions and their graphs. We're going to look at the different things that we can do to change the graph of the basic quadratic function fx equals x squared. The first thing you'll see in this first slide is that the parabola can get wider or skinnier and it can flip upside down. Fx equals x squared is the orange graph, but let's look at what happens when in the teal graph. So if we had an equation, for example, like fx equals 2x squared, that would create this teal graph, which is skinnier. So that means that when a is less than 1, the graph gets skinnier. Next, let's look at the purple graph. You can see that the purple graph is wider. An example equation here would be fx equals 1/2 x squared, meaning that when a is less than 1, a fraction of some sort, the graph becomes wider. In both of these cases, though, a is greater than 0. If a is less than 0, so a is a negative value, that's how we get this flipped upside down graph right here. So if let's keep with the color scheme. If fx equals negative x squared, for example, that's when we get this upside down graph. So anytime when a is negative, graph is upside down. And this can be true for a wider and a skinnier graph as well. So like if we had negative 2x, let's go ahead and add in another graph here. Go with pink. If we had x equals negative 2x squared, then we would have a skinnier upside down graph. So A tells you how wide or skinny the graph is and which direction it faces. So let's keep in mind this equation, and A changes the width and the direction. Alright, so what else can we do to this graph? Well, we can also shift the graph left and right. We shift the graph left and right by adding a value of h here. So if we have in the teal graph, so again, sorry, the orange graph is our basic fx equals x squared. That's a equal sign, kind of looks like a z. Sorry about that. Equals x squared. So the teal graph moves the graph right, and the equation for this would be fx equals x minus 2 squared. So here's our h value of 2, and that moves the graph right. Then looking at our yellow graph, we would have fx equals x plus 2 squared. That would move the graph left. So the h value determines left and right, or a horizontal shift, as shown here in the left-hand column. And we can also shift our graphs up and down. We shift the graph up and down, or a vertical shift, by adding a k. K tells you which direction to shift the parabola. So, orange graph again is just our basic, stick with the same color, is just our basic fx equals x squared. And the teal graph is fx equals x squared plus 2. That shifts the graph up. So as you can imagine, probably the yellow graph would be fx equals x squared minus 2, and that shifts the graph down. So these are our vertical shifts. So here's just kind of a summary of all of the different things that can happen, and this is a format that you might see the quadratic equation in, and it would help you easily graph an equation without having to actually plug values in. Okay, so here in summary, if we put everything together, this A value determines width and direction. And by direction, I mean direction it faces. And then we've got H, which determines a left or right shift, otherwise known as horizontal. And then we've got K, which determines up or down, otherwise known as vertical. So with this base equation, you should be able to graph any quadratic equation. The last thing I want to talk about today is the vertex. So thinking back to that equation again, H and K actually give us our vertex point. In this graph right here, the vertex is 0, 0, so not very exciting. It's just our basic equation again. But if you look back here again, left or right shift tells us how our x coordinate changes. And our k value tells us how our y coordinate changes. This would be the vertex h, k. But if we shift our graph, let's say our graph ends up here, based on after moving it around, we have a new vertex over here, and it will be determined by the shift to the right and the shift up. Those values are h and k in an equation. So let's just say that this vertex right here is 3, 1, because it's been shifted to the right 3 and up 1. The equation for this would be fx equals x minus 3 squared plus 1. We didn't change the width or the direction, so there's no a value here, but you can see that we shifted to the right 3 and up 1 from our original equation, which is just at 0, 0. Let's use these rules that we've just talked about and try some of our homework problems to see if we're understanding all of these different possible shifts to quadratic functions and their graphs.